Find each of the following integrals. And the first one is the integral of 2x over x plus 1. You can do this by substitution, which we're going to start in the next example, but you can do it without as well. So, what I could do is rewrite this as 2x plus 2 take away 2. The top is just 2x, it's still 2x, but I've just written it as 2x plus 2 take away 2 over x plus 1. Well, that's the integral of 2x plus 1 over x plus 1 take away 2 over x plus 1. Here those cancel, so I've got the integral of 2 take away 2 over x plus 1, and that gives me 2x take away 2 ln mod x plus 1 plus a constant. Now for part B, 2x plus 5 over x plus 1, we can do this using partial fractions. Note both linear factors in the bottom. So we can say, well, 2x plus 5 over x plus 1 is going to be a over x plus b over x plus 1. Going clearer fractions by multiplying right the way through by this gives us 2x plus 5 is identical to a. Now multiplying by this for this term, the x's will cancel, so we'll have ax plus 1, and in a similar way this would be bx. So if we take x is equal to 0, we get 5 is equal to a. If we take x is equal to -1, then what we get is that 3 equals, remember this term will now disappear, and it will be -b, which means that b is -3. So we're now integrating 5 over x, take away 3 over x plus 1, and that's going to give us 5 ln mod x, take away 3 ln mod x plus 1 plus a constant. And finally we have this one, 7x squared plus 8x take away 4 over x plus 1, x squared plus x minus 1. Now you should note here that because of the minus 1, this quadratic would dip below here. But if you look at it, it's not easy to factorize. So you can still use the quadratic form and it will work perfectly well. So in other words, 7x squared plus 8x take away 4 over x plus 1, x squared plus x take away 1. We can do that as a over x plus 1, treating the linear factor in the normal way, plus bx plus c over x squared plus x take away 1. Let's go clearer fractions by multiplying through by this. And so we have 7x squared plus 8x take away 4 is the same as a x squared plus x take away 1, and then bx plus c into x plus 1, and that's just because of the cancelling that happens when you multiply through by this. If I take x equal to -1, the left-hand side becomes -5, and the right-hand side, remember this term will disappear, but this, if x is equal to -1, becomes -1, and so we have -a, which means that a is equal to 5. If we now look at x squared coefficients, on the left we've got 7, on the right you'll have a plus b. We know that a is 5, so that means that b is equal to 2. And if we look at the constant term, we've got -4 on the left, And if we look on the right, constant term here would be negative a, and we'd get one here which is plus c, and we know that a is equal to 5, so that's going to give me that c is equal to 1. So we're now integrating 5 over x plus 1 plus 2x plus 1 over x squared plus x take away 1. That's going to give me 5 ln mod x plus 1. And if we look at the second term, the top is the differential of the bottom. So just like the last example, that is going to give me a ln mod x squared plus x take away 1 plus a constant.